You're the gumshoes for math.
Homework Hotline, what is your emergency?
Okay, hello everyone. Welcome to the Homework Hotline. Do you have a homework problem that is a mystery? Call us. We're here to help you crack it wide open and solve for the answer.
You can think of us as your private eyes for math and science.
I'm Nathan, and this is Becca over here. We are the gumshoes for math. And over here we have Sam, who is your science gumshoe.
Sorry, I got gum all over my shoes. So we use our sleuthing abilities every day when we teach. I teach science at the Contemporary Learning Academy, and Becca and Nate teach math over at Emily Griffith High School.
Yeah, and we are live every Tuesday and Wednesday from 4:30 to 5:30 p.m.
Call us here at 720-424-1666. The number's right up there and will be for most of the show. When you call in, we can investigate the problem. If we need clarification, we'll ask you to make sure that we are giving you the best information for the questions.
Yeah, and you can watch this show in a plethora of different ways. So if you're ready, you can watch us for live broadcasts on Comcast Channel 22 or on Prism TV Channel 8007. If television is too old school for you, you can catch us on the internet at livestream.com. You have to search for DPS TV 22, one word, or Facebook at EG Homework, or YouTube at Denver DPS TV.
And since today is Wednesday, we're also going to have a science demonstration with Sam over here. If you haven't noticed, we've been dropping a few clues about the topic of the demo.
Yeah, so a bit later in the show, we'll be delving into forensics a little bit.
So if you prefer to call us, we understand that you also like to use, though we prefer for you to call us, we also understand that you like to use social media. We have Jeff monitoring our social media for your questions.
Yes, that is correct. My name is Jeff. I am an intern here at DPS TV, and I am also known as the Trivia Master. And I have a trivia question that I'm going to put out to you guys, and you guys want to answer that question, and you might even be able to win a prize if you answer the question correctly. Okay, so pay attention to that. So I'm going to be perusing the social media boards for your guys' questions, and then I'll be sauntering them over to everyone over here so they can answer the question. So why don't we go to that trivia question right now, the main trivia question that you guys want to answer. This is a good one, actually. This is one that goes very deep, if you will. What is the deepest shipwreck ever found? The deepest shipwreck ever found. So that is our trivia question for today. So if you know it, call in, let us know, and you could win a prize.
Awesome, thanks, Jeff.
Sure.
All right, so let's also give you our other contact information. We mentioned that Jeff gets your stuff from social media, but let's tell you how to do that. So calling up there, but then social media, you can send in your questions to us on Facebook or Twitter at EG Homework. You can text your questions to us at 970-680-3771 or send them to us via email at homework@emilygriffith.edu. So get your questions to Jeff by the end of the show and we can answer them live. Speaking of Jeff, let's go back to him and see what questions are waiting for us.
All right, well, we have a very interesting question that is waiting for us right here. And this is a math question. So, and I believe it has to do with order of operations. So our math whizzes over here are going to have to take this. But it says, I need to solve the following problem, but I think I'm getting the order of operations wrong. Please help. And here is the problem. 8 times 5 divided by 10 plus 4 squared is the problem. So is there a certain way we can solve this? Or?
Yes, we'll go through that. So they did mention the order of operations. If you go to my screen, I have that problem written there as well. But order of operations, one way to remember them is, or one way you may have heard them referred to as, is Pemdas. And one way to remember that little acronym there is, please excuse my dear Aunt Sally. I think that's kind of antiquated. I think we should come up with a new one, but I guess it works, right?
Right. Everybody seems to remember it still. Like,
yeah, it is. It's boring as could be, but
maybe we should work on a new.
We need to work on something that will catch on.
Yeah,
Let's think of
something
something.
hip.
All right, we're on that. We're on that for next time. But so what it stands for, please excuse my dear Aunt Sally, P stands for parentheses, meaning we need to simplify anything inside of parentheses if we have anything to simplify. Let me be clear about this. Let's say I saw something like this, 2 parentheses 4, and it's on the left side of my screen there. That is not referring to parentheses. Those parentheses are talking about multiplication. What we mean by parentheses is if we have anything that's inside of parentheses that needs to be simplified. That's what we mean by parentheses. I notice that misconception a lot. E stands for exponents, so any powers, power to 2, power of 3. This all also includes radicals, like square roots. That's another thing, is people don't know where do those fit into order of operations. Those radicals are also considered exponents. Multiplication and division, those go together. That's another common misconception, is that because the mnemonic phrase is, please excuse my dear Aunt Sally, people think that multiplication comes before division. It doesn't. These two go together, and we do them from left to right. But they stand for multiplication and division. And we have to go from left to right. So if division is further to the left, we have to do that first. Last one, addition, subtract, or A and S, that's addition and subtraction. Same thing goes with those, is we do them from left to right. We don't do all the addition first and then all the subtraction second. We do left to right addition, subtraction. That's just because they're so closely related, they're almost the same thing. So here's how we would actually perform this, and I tend to do this, one step at a time, and your work should be shown this way as well, where each step that we show, it just goes, we're showing each step down like that. So parentheses, you might notice there are no parentheses in here. You can kind of check that off and say, all right, we're done with that. Exponents, that would be our next step, and we might notice that we have this 4 squared over here. That's something that we have with exponents we need to simplify. So we're going to do 4 squared. We're going to perform that operation. 4 squared is the same thing as 4 times 4, which gives you 16. And then everything else gets copied below it because we didn't touch anything else yet. So I still have this 8 times 5 divided by 10 plus 16. So there was my first step. I've got my exponents done. Next, I'm doing multiplication and division from left to right. So you might notice I have multiplication and I also have division. I have to do from left to right. So my multiplication is further to the left, which means I'm going to be doing this 8 times 5 first. So I'll start with that, 40, and then everything else gets copied down below it. I'll continue, still doing my multiplication division. So now that means I can hit my division. So I've got 40 divided by 10. 40 divided by 10 would give you 4. And then everything else I'm going to keep copying. Now all that's left is that plus 16. So I'm done now with my multiplication division. All I should have left is any addition subtraction, and that's the case. I have a 4 plus 16, so I will perform that operation, and I get 20. So I used to tell my middle school students this, is that your work should kind of look like an ice cream cone, because what we're doing is we're simplifying. We're taking something that's really complicated, and we're simplifying, 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 making it smaller and smaller and smaller. So it should almost look like an ice cream cone the way you show your work. So yeah, I hope that helps. Big thing, I pointed out the misconceptions, common misconceptions. Make sure you don't fall for those, but I don't know. What did you think?
While you were doing that, I was looking up more acronyms.
I was also doing
Pemdas.
that.
Did you? Okay, what'd you find? What'd you find?
I found a lot of inappropriate ones and
I
some
did
kind
too.
of boring ones. I can give you a few of mine, and then I was like, I can come up with a better one. So I was actually trying to work on. But do you want to hear some of the less interesting or less offensive, I should say?
Yeah.
Less offensive, yes.
Sorry, I'm not going to give you. There's some good offensive
There are some
ones.
shockingly offensive ones for
also my
a math
Really?
order of operations.
My thing is not working at the moment. It's been really slow. If I can, I'm trying to pull
I was
back
like,
up
that
the
doesn't
website.
really fit.
Yeah, that's not. Oh, okay. Purple elephants may destroy a school.
Oh, I saw that one.
I like that.
I
Please
like
execute my deadly anteater silently.
I like pancake explosion. Many deaths are suspected.
Oh, that's good. It's like a headline.
Oh,
Yeah.
that's fun.
Please eat my dear annoying sister.
Okay.
Peanuts ended my donut addiction Saturday.
Oh, that's pretty good. That is pretty good. Oh, there's an appropriate one.
Those are all way
Put
better than
every medical device away safely.
Nice.
It's a little bit specific.
kind of bland
if you
as
were learning
well.
PEMDAS in a nursing school,
That would be
a great
good.
one.
Yeah. Or people eat more donuts after school.
Oh, that's good. I would
that's
use
my
that
favorite one.
I would use that one.
I'm
right
going
there.
to say that. That's
Yeah.
my favorite. Please eat more donuts after school.
Well, it's people eat more donuts after school,
But
but
I
please
like
eat more
please
donuts.
because it's like just wait on your sugar intake just until I don't have to.
That's
deal with
true,
you anymore.
right?
That is what I want to say.
Because you're going to
always.
crash in about
After
30
school, not
minutes.
before
So
My
school.
students live off of simple sugars, and if you're one of those high school students that lives off of sweet tea and Cheetos and candy, you should take a look at your life. Take a look at your choices.
look at your
and
life.
also please
Please.
eat more donuts.
And
after
please eat
school.
more
I was
donuts
gonna
after
say
school.
Yes.
After school.
All right, we're going to use that from now on.
Yeah.
Okay,
Let's
perfect.
Try to
Okay.
start
I'm
a
glad
trend
we
here.
settled that.
All right.
A movement.
I feel much better now.
Yeah.
All right, Jeff. Let's go back to Jeff and find out what other questions are waiting for us.
All right. Well, I always get hungry, and eating donuts after school or any time for me is great. But another thing I like to do is to go to the convenience store, and you pick out those different kind of candies that they have. Well, we have a specific question. Speaking of sweets and what was it? Solid sugars or whatever. Anyway,
Simple sugars.
Simple sugars. That's right. Yeah. Well, we have a simple sugar problem over here, and that says. Well, I'm just going to read this word problem to you. It says, my name is Joshua Palmer, but my friends call me JR. Sounds like a nice guy. I don't know why, though. I am entering my school's science fair, and I'm doing the science behind candy that floats and sinks to the bottom of a cup of water. I have noticed that the Skittles and Laffy Taffy both sink to the bottom of the cup, but if I blend the Laffy Taffy into a certain shape, it will float. Can you please tell me why?
Yeah, absolutely. I can tell you why.
right.
So, JR, whoever you are.
JR, yeah.
The reason that your candy sinks or floats is related to something called density, and I'm just trying to pull up a quick image here to show. If we get down to my screen, I'm just going to talk off of this image. So, density is sort of a key idea when we think about another key idea in physics called buoyancy. So buoyancy is how much something or how well something floats in a liquid. Typically, we're talking about water. We don't have to be, but typically we are. So, and one of the main reasons we're probably interested in buoyancy is that humans use buoyant objects on water all the time, specifically boats. But having a good understanding of how things float in water and why they float in water is really key. And so maybe that's something that you can explore in your science fair project. In this image that I have here, what we've got is this is just sort of a simplified diagram that shows two forces acting on an object that's floating in water. You've got the force of gravity pulling it down, and the force of buoyancy pushing it up. In general, right, gravity is going to bring all things toward the surface of the Earth until they hit something that's more dense than them, or that's dense enough to support them and keep them up. If you think about something floating in the ocean, let's imagine, so here's gravity pulling down on this thing, density pushing up, and then the density of the object here. If the object is more dense than the fluid that it's in, the object will sink to the bottom. If the fluid is more dense than the fluid will keep the object suspended. Now in JR's question, he mentioned that he saw both Skittles and Laffy Taffy sinking to the bottom of a cup of water, which indicates to us, without really doing any more work than that, we can just say Skittles and Laffy Taffy are more dense than liquid water. Now that actually makes a lot of sense because Skittles and Laffy Taffy are solids, and they're both kinds of candy that don't tend to have big air pockets inside, as far as I know. So that would mean that typically a solid is going to be more dense than a liquid, so it makes sense that they would sink to the bottom. But JR also mentioned that he was able to make the Laffy Taffy float by bending it into a certain formation, and I'm betting he bent it into a formation that looks something like this. I actually found an image, somebody online, who did probably almost exactly what JR did. This is just a Laffy Taffy floating in a cup of water. The Laffy Taffy has been bent around so that it has volume. It's sort of added volume to its area. So density is a calculation. It's the mass that an object has divided by its volume. And by changing the Laffy Taffy around, by pushing it so that it has this little pocket inside of it, JR has expanded the volume that this Laffy Taffy occupies and created a space where there can be air inside, sort of in this little floaty pocket right here. And that means that the air, which is much less dense than water, which is why air doesn't sink into water, that is sort of balancing out the density of this Laffy Taffy and allowing it to float. So that's the reason, JR. It's all about density and buoyancy. If you have any follow-up questions, please send them in.
All right, back
Cool.
to Jeff.
Oh, back to me.
Yeah, back to you.
All right, awesome. Well,
Give us more questions.
All right, I will. Actually, one of my favorite candies was Sugar Babies. I don't know if you guys remember those from way back in the
What
day.
are they? They're
I
caramel?
kinda
Babies are
Yeah,
the
they're-
super simple little.
The little ones.
Because they're sugar daddies.
Sugar Daddy was the
Where
big
the
one.
big one, but it's the same candy as the
Yeah.
sugar babies,
It's
but
like
they're
caramel, right?
Right.
yeah, caramelized sugar, I think. Yeah.
Yeah, I wonder how dense those are. That's just my
You
question.
should perform an experiment.
I probably should, yeah. Well, right now we're going to move over to a math question. And this has to do with graphing. And it says, how would you graph the equation y equals parentheses x plus 3 parentheses squared plus 4? How would you graph that equation? And I'll leave it to the experts to explain how to graph the equation.
So there are a couple of shortcut methods at this one. I'll take this one unless you are really excited about it.
But you look pretty prepared for it.
Yeah, I've been setting up for a couple
I'll
minutes
let
here.
you do that.
Look, there's a shortcut for this, and if you're doing this, you probably are familiar with the shortcut. If you're trying to graph this transformed function, then you've probably already seen the shortcut, but I think it can be a little confusing if you don't really understand why we're doing it or how that shortcut comes about. And especially what we see here is if you look up what I've done, I rewrote this. So the original equation was y equals x plus 3 squared plus 4. So here's what I did, and you kind of see a lot going on. I'll kind of talk through it. But this is a transformation of what's called a parent function. So we have a parent function, I'll write down here, because I'm going to graph this in blue, y equals x squared. And you'll notice up here, I rewrote this as f of x, and the reason why I did that is because I think it makes it a little bit more clear what we're going to be doing with this transformation. But what we're really kind of doing here is we're saying, and I'm going to rewrite this too, f of x equals x squared. And what I'm going to do is I'm going to graph that inside of here before I do anything else. So I'm going to write that up here too. F of x equals x squared. And we're going to kind of see what happens when we make some changes to these graphs, like we add something to the x variable or we add something to the entire function. And then we'll talk really quickly about the shortcut and why it kind of works. So first thing, if I were to just graph this parent function in yellow down here, y equals x squared, or f of x equals x squared, you are probably all too familiar with your teacher's method and everybody's method really of doing the really tedious task of coming up with a whole bunch of values, plugging them into the equation, plotting a bunch of points, and then sketching that graph out. So I'm going to do that now. I'm going to pick a few points, and we usually do like -2, -1, 0, 1, and 2. the reason why your teacher always selects these is because they're really easy to plot. They're really easy to evaluate. So when we do this, we're saying, looking at my parent function, I'm going to say f of x equals x squared. Well, I'm going to say, what is f of negative 2? And I'm going to get negative 2 squared, which is going to be a positive 4. I could do this again. I'm going to do it just one more time. F of negative 1 equals negative 1 squared, and I'm going to get positive 1. So all we're doing is plugging in this x value into the function, and then we are evaluating it and seeing what comes out. So if I do this again, I'm going to get f of 0 here, and 0 squared is 0. F of 1, so 1 squared is 1. F of 2, so 2 squared is again 4. So I can quickly plot this and say negative 2, 4 is 1 point. And hopefully at this point you're already pretty familiar with this particular parent function. This is a quadratic, so it's going to form that parabola shape, that curved shape. But we're just plotting it so we can see what's happening with these changes. And you should also note that these are symmetrical. So, trying to do a nice curve here.
Beautiful.
So that is my original function. Thank you. F of x equals, I can never see my pen. F of x equals x squared. Now, what happens when I applied this first change that we were asking to do, x plus 3 squared? Like, what does that actually mean? All it really means is when I originally, let me erase this so I have some space. Whereas I originally just said, okay, my value is x, I'm going to plug that in. Now we're saying, oh, I don't know what I just did. I guess nothing. I don't know what's happening, but it's still working, so let's see if I can scroll this back up. All right, that's fine. All right, what is going on here? So I'm going to say, what am I doing when I actually say f of x plus 3? Well, I'm still doing this. My function was still x squared, but now we're saying f of, and if I want to evaluate this negative 2, we're saying f of negative 2 plus 3 is x squared, and we're kind of evaluating inside that function. So we're actually evaluating f of 1, so equals 1 squared, so it's going to equal 1. So instead of having negative 2 equal 4 like I had here, I'm evaluating x plus 3, and now it equals 1. Right? Because what we're doing is we're shifting, we're changing the value that we're evaluating. We're changing that f of x. We're adding 3, and then we're evaluating it. And we can do that with all of these. So if I was doing f of x plus 3 again equals x squared, we're saying f of negative 1 plus 3 is f of negative, so f of 2 equals 2 squared, and we're going to get 4. Right, so that's what we're doing. We're first taking our value of x, we're plugging it in, we're saying, I'm not going to do, for example, this next one, I'm not going to do 0 squared, I'm going to do 0 plus 3 squared. And then I'm going to draw this, and I'm going to get 9. And I'm not going to do 1 squared, I'm going to do 1 plus 3 squared, or 16. You notice these numbers get pretty big. I'm not going to do 2 squared, I'm going to do 2 plus 3 squared, which is 25. Now, the problem with this is everything's been kind of shifted, and we'll talk about that shift that you saw. So we actually should go back and evaluate some more values to see what's happening. And this may be just a really long way of doing this and showing it. So I actually kind of am seeing that, where'd it go? That this number is the same as this. So I'm kind of wondering if I shift this to negative 3, what's going to happen? Well, I'm going to say f of negative 3 plus 3, which is f of 0, which is going to be 0 squared, or 0. So over here, I'm going to get 0. And you'll kind of see that everything is shifting back. If I plug in negative 4 here, I'm going to get negative 4 plus 3, negative 1 squared, and I'm going to get 1. So you should kind of see that everything's shifting back, So what's actually happening in your graph, and this may be the shortcut that you've seen, see if I can find some space to write. When I evaluate f of x minus h, if I make a change in here, it's going to create a horizontal shift. So you should notice that all the x values are shifting by this value of 3 here. But everything's shifting the opposite direction. Everything is shifting to the left. So if I were, hopefully this isn't too confusing, if I were actually evaluating this, I would say, look, everything is shifting 3 units to the left. So I could actually just shift every point that I had 3 units to the left. So 1, 2, 3. Now I don't know where everything's going on my paper. Maybe I can do that. And then I'm going to shift this 3 units to the left, and I would shift this, and I'm running out of space there. But every unit is being shifted 3 to the left. And this is sometimes a little hard to see. So this f of x plus 3 has shifted everything horizontally. And because if you played around with this, I don't want to keep on doing this with too many numbers because we could do this for like 25 minutes. You would see that all the values, our graph looks exactly the same. It's just pushed over to the left. And one that's a little bit easier to see is if I do f of x plus 4, like here, for example, all we're doing is evaluating our function f of x, like right here, and then we're adding 4 to it. So if I evaluated -2, let me just highlight this whole row. If I evaluated -2, I would get 4, and I want to evaluate this entire function and add 4. So we're literally just saying, let's add 4 to every piece of our function. And you notice what that should be doing is shifting all of your y values up by 4. And you kind of see I got 8, 5, 4, 5, and 8. There's that symmetry where it looks like it's going to repeat on both sides, which is true. So if I were to do this, I would literally be shifting everything up 4 units, up 4, and my graph would look like this. And I know there's kind of a lot going on here. So ultimately what we were saying is if I'm combining both of these, then I'm saying if I want to combine both of these shifts, oh, that's interesting. See if I can clean that up a little bit or no. Oh, too much. All right. So if I'm combining both of these, what we really want to do is say, let's shift it this way, oops, and let's also shift it this way. So what we're really doing is we're combining 2 shifts. So you can kind of see what happened individually, but what we're doing with this is we're saying, let's move everything to the left 3 units and also up 4 units. What's going on there? So I could literally go pick a few points, 1, 2, 3, and then 1, 2, 3, 4, and then I do that with every point. 1, 2, 3, 1, 2, 3, 4. And then this other point, 1, 2, 3, 1, 2, 3, 4, so I'd be up here. So my new graph after all of these shifts is going to be all the way, it will look exactly the same, but it will be moved to the left and up. This is kind of a hard thing to like show the transition without spending a lot of time. But if you play around with this table of values, and your teacher probably did this with you, you kind of start to see why inside, even though we're adding 3, we're actually moving everything the opposite direction.
Yes.
But with the y values, we're just straight adding 4 to the y values. So everything is
so it
moving
just
up.
moves up.
Yeah.
Yeah. Man, there have been so many times I just tell my students, just trust me, just trust
Yeah.
me, just trust me on this one.
Because you could spend
so hard
days
to-
doing this. And,
Yes, it's so difficult to explain and wrap your brain around why that happens. But yeah.
and why the x is backwards.
Right, exactly.
Yeah.
Just trust me. It's the opposite of what you see, which is not a great teacher move to do, but
But
really,
sometimes.
You have to do it sometimes.
Yeah.
sometimes you got to do it. Just
Yep.
trust me. You don't want to hear the explanation, right? Yeah, I don't know. No, I don't know. You did a great job.
Thanks.
All right, well, we're going to take a little break, and when we come back, we're going to be in the science lab. Woohoo! See you soon. Science!
Healthcare is going to continue to grow as a field, and pharmacy technicians are going to continue to be an integral part of patient care.
It can open a lot of doors for me as far as getting my foot in the door in the health industry.
Part of patient safety is having qualified personnel in the pharmacy environment. Employers will be looking for that as one of the qualifications. Once a student begins the program, you are enrolled in the hybrid portion of the course where you do online work and then come in and do lab work in the classroom. That portion of the program takes around 5 to 6 months. A requirement of the program is to complete 2 clinicals, and one in an institutional setting, and then the second clinical would be more in a retail environment.
It is more affordable than every other school that I've looked into as far as pharmacy tech programs go. And you can also get different grants to come here. I was actually able to get a grant for this program, and so that's really what made me decide on Emily Griffiths.
Once you've completed the coursework and both of your clinical settings, then the student has completed our program and is now ready to go and sit for the national certification test.
One of my goals in life is to be able to help people in some way, so that's why I chose it.
A lot of people think you have to be really good at numbers, and that's not really true. You do have to be good at solving problems. So we take students through all the basic fundamentals of accounting and hope to give them enough skills to go out and work in an entry-level accounting position.
Welcome back to the science lab desk thing, guys. It's great to have you. We're going to be doing a little bit of forensics today, which is to say we're going to do a little bit of fingerprint dusting. Now, there's a lot of ways that you can sort of DIY fingerprints. We're using a fingerprint kit. These are also pretty inexpensive to pick up if you're interested in trying this. But let's just kind of get right into it. So the first thing is, guys, if we're forensic scientists, okay, I have here evidence. Okay, evidence was marked by criminals. Actually, no. This evidence was marked by people who work backstage, but who I assume are not criminals. But one never knows. Okay. So anyways, each of these objects has some fingerprints on it, and I don't want to contaminate it, so I'm wearing gloves, and I need you guys to do the same. Oh. So I have 2 kinds of gloves. I have extra large and large. Becca, I know that doesn't really suit you, but you just got to work with the large.
Come
just
on
go
now.
with the extra
Here's
large.
the extra large for you.
Yeah.
I'll wear large, actually.
I do feel like they're a little small in general as gloves go, so we'll just get those
They're
on.
not too bad.
This is an important first step in fingerprinting because what we're going to be doing in fingerprinting is we're going to use powder to reveal, in fingerprinting we call it developing, but essentially you're going to reveal the fingerprint because fingerprints, when we touch things, we leave oils all over the place. Our skin generates oils, and those oils are normal and healthy. They help our skin to be functional, but it also means that we leave a trace everywhere that we touch. Okay, so I have 2 ways that we're going to fingerprint. Becca's actually going to help us with the second kind. So guys, I'm going to have you guys help me with the first. Okay. So one of the first things you need to do, oh, and actually, Becca, there's a piece of white paper behind you. Would you just grab that for me? Okay. So the first thing you need when fingerprint dusting, and guys, I'm going to have you guys each dust one of these mysterious clear jars.
Vials.
So we will take a look at those there. There's fingerprints somewhere on there that we've got to find, okay? Now, if you have fingerprint powder of some kind, and again, there's a lot of different types of powder, cornstarch and talcum powder that you can use as sort of a DIY version of this, but black fine powder is really the best thing. And what I'm going to do is just use a blank piece of white paper just to sprinkle a little bit of powder on for our use. This is also an easy way to clean up afterwards. We can then just lift the paper up and put it back in whatever dust we don't use, whatever powder we don't use. Okay. So I'm going to use Nate's just as an example. Now, one tricky thing about fingerprinting is there's some technique involved. Okay, you want to be really gentle with your brush. So this is called a fiber brush. If it comes out, it's called a fiber brush. So, and with the fiber brush, what we want to do with the fiber brush is get some powder onto the prints so that we can develop them. which is, again, the word for revealing them. But we don't want to wipe the prints away. So we really want to have kind of a light rubbing motion. Fingerprint experts, like people who actually do this kind of thing, there's a couple different ways that they do it, but what I have read and looked into is they seem to prefer a swirling motion like this, very light on the surface of the thing that you're doing. So you're going to very lightly be going along the surface until you see the powder start to pick up somewhere. Those are going to be your prints. Now again, you don't know where they are, right? If you were coming into a crime scene, they're somewhere on here.
Yeah.
Yeah, I was looking. I couldn't find any, actually.
So we're going to be looking for those, and then once the dust, the oil picks up the dust, okay, you can go over that spot a little bit more, but again, we're not really making too much contact because we don't want to rub the prints away. Okay? You guys ready to give it a shot?
Yeah.
Okay, go ahead and grab your brush out there, Jeff.
Okay.
Again, Becca, don't feel left out. Yours is way cooler.
Okay.
Okay?
Well, now I feel left out.
Oh,
I didn't get the way cooler
Nate,
one.
I don't really mind if you feel left out.
That's fine. I understand. I think you should.
Oh, yes, indeed. Excusez-moi.
So how much
Excusez-moi.
dust do I want to put?
Okay, yeah, so right, you just want to lightly dip it in. Nate, what you just did was perfect. That's plenty of
Okay.
dust right there. And so Nate's going to
you're
start
putting on
the
your blush.
swirling action.
Aw.
Now also, Nate, you have kind of a nice sweater, and Jeff, I'm sure that's important to you. The powder is not
Very
going to
expensive.
stain or anything, but we also want to try to not get any powder on you if possible.
Okay.
So just keep it out a little ways from you as you do
So I
your
want to just kind of do like a.
Yep. And for folks at home who are watching, just kind of watch Nate's brushing technique there. He's doing a pretty good job. I don't know if we'd hire him
technique.
right away at the
I
forensics
probably could
lab,
practice a little bit more, but.
We might have to. So Nate's
Oh,
gonna
wait
go
a
down-
minute.
Oh, Nate, you find some?
I think so.
Oh, Nate's got some fingerprints, folks. Exciting stuff. Okay, so Nate, you just want to get a little bit of powder on there.
Is that a
Okay.
fingerprint?
Yep, absolutely it is.
Okay.
That's great. Get a little powder on there. Go ahead, Jeff.
Yep.
Just
Oh, okay.
work your way around until you find, and Nate, maybe show Jeff your fingerprints just so he can see how light they are.
I think
Yeah,
I
it's
found some.
very
Did you find
light.
some?
Oh yeah, you got a whole.
think I found
a whole
some.
finger.
I
Yeah.
got the
You got a
criminal.
little nub.
Someone's got greasy fingers back there. Okay, so anyways,
Just the one.
yeah, so and there actually should be a few on there. If you go around, I have them touch both sides of the jar so that it wasn't too much of a.
Oh, I got another one. This one looks better.
Look at that. Better be careful or Nate's going to leave teaching and end up working on the crime lab.
Dexter. Well, not Dexter.
Right, not Don't be like
Maybe
that.
that was a bad example.
Okay.
Without the killing. And
Right.
Stuff, yeah.
So, Nate, do you have that location where you've got your
I
prints
do,
on there?
I do.
Okay, great. So,
Should I just set this down
yeah,
here?
just go ahead and set it down on the paper. Now, one last thing you can do just to try to get any last little bits of loose powder that aren't attached to the oil, you can take your object and just tap it lightly to try to
okay.
knock off a little bit of excess powder. Excellent. Okay. Now what we're going to do is we have tape. This is called fingerprint tape, but really any kind of clear
Scotch
plastic, well, packing tape really, like it should do the job just fine. This is special stuff, but you don't need to have special stuff. And what we're going to do is we're going to actually transfer these prints. Okay? So Nate, I'll let you do it first here. Can you grab the scissors up for me?
I can.
Go ahead and cut a little strip there. Okay. Now, what Nate is going to want to do here is he's going to take this, and again, the gloves are really crucial so that we don't get too much contamination here. And really, to whatever degree we can, don't touch too much on the sticky side. Okay? The edges are fine.
Oh, I see. What you mean.
But what you're going to do is you're going to try to lay it on there nicely, Nate, without
is.
getting any air bubbles. Okay?
Okay.
Thank you.
Excellent.
Good teamwork.
Excellent. Thanks, Becca.
No air bubbles.
No air bubbles, and try to get the center of the tape right over the prints. This is going to allow us to pick up the prints and transfer them. Okay. Definitely. And Nate, if you just want to kind of push that tape down across with your gloved hand, that should be totally fine. You shouldn't contaminate. Let's also do the same for Jeff.
Okay.
Becca, can you cut me a slice there? Excellent. Becca's going to hold it stable for us. Jeff, there's your tape.
On the edge.
On the edge, that's right.
Oh man.
It's okay if it's so get it
Why is the tape attracted to my glove?
a
Static.
little bit of static.
Oh.
It's Becca's fault. It's just a static monster.
Static monster.
Okay, so yeah, over the fingerprints
Okay.
to pick them up. Gotta see Nate. Oh, yeah, that is it right there. Oh, okay, cool. Okay, and then so the last little piece here is to pick up the, or to take the tape off, and then what I have here is sort of a mock card. I don't know if we can see this, but essentially this is just a blank index card on one side with sort of, it's sort of shiny paper, so it's gonna show the fingerprints fairly well. And then on the back side, there's a place where you can write details about the case. Right, so the case number, type of offense, all that other good stuff.
You know, I'm just thinking this would have been a great thing to have when I was a kid, and I knew my sister was going through my stuff.
Would have
but
been
I
so
couldn't
great.
prove it.
You could have labeled one of these cards and brought it to the parents and said, "I've got
Got
it."
her fingerprints.
Okay, so
And they'd be
Nate,
like, "I don't care."
if you could do me a favor, you're gonna pull off that tape,
All right.
stick it on the front here.
Oh,
Jeff?
I shouldn't have.
Yeah.
Go ahead and pull off that tape, stick it on the front here. Let's see if we
okay.
got any kind of transfer. Now it is kind of tricky. In general, doing this the first few times, getting powder on there with the brush, but making sure that you don't rub too much is really kind of a tricky thing to do. It definitely takes a little bit of technique and a little bit of practice. And they come out a little bit smudgy, but they should give us fingerprints that are good enough. Nate, can you still see your fingerprint on there? Can you
can.
kind of point it out to us? I don't know if we can get a close-up shot of that. Let's see
Right
if,
there in the middle.
Let's see if we can get a close-up shot of that. Yeah, right there in the middle. Probably not
Which way? This
super,
way.
there you go. Not super obvious on the camera, but you can see that print in the middle.
Yeah.
At this point, also what would often be done is, close-up photographs of the fingerprint, and also you can look at it under a magnifying glass to see it in more detail.
And digital, right? They do those like scanning millions
Right,
of points.
and today what they do is a digital scan of it, which gives us a really
See the
accurate
lines
view.
in it.
Can you see it a little bit there?
You can see the
Jeff, did
lines
yours
in
come
it.
out
It's
sort of
just
light?
It came out a little light, but I think it was Professor Plum with the candlestick.
Oh,
No, just kidding.
get that, Professor.
Yeah, this one you can see.
Outline a little bit.
Is that a whirl or a loop? Can't
Loop.
tell.
Okay, now, as you can probably tell, this is sort of a little bit of a finicky system. And if you are a true detective out there doing your work, it may be a little bit annoying sometimes to have to dust for fingerprints. Maybe you don't have the smoothest of strokes, and you might be picking up the oil a little bit. So forensic scientists have developed magnetic powder. And magnetic powder, Becca's going to do a little bit of forensic work for us here with the magnetic powder. And we don't actually even need to pour it onto paper because it's magnetic. Okay, so even though it probably doesn't look like it, this is a magnetic brush.
Okay.
Not really a brush at all. But it's called a magnetic brush because you're brushing for the fingerprints. Back here we have a plunger, okay? That it goes up and down. When it's down, it makes this tip magnetic. When it's up, it's non-magnetic.
Can you hold that up to the camera so they can see?
Let's see if we
So
can get
when
a
it's
close-up
up,
of that.
it's non-magnetic, but when it's down, it's being magnetic.
Exactly.
Okay.
Okay.
Oh, so that's like an internal mechanism, so
Yeah.
we can't see it.
So different from the finger powder that we used with Nate and Jeff, I have here some magnetic finger powder. And hopefully we can get a close-up shot of this because it really is cool. And also Becca can pull it right out of the jar. So Becca, why don't you put it on non-magnetic first and just stick it in there, and does anything happen?
Nope.
No, again, it's not magnetic. Okay, now why don't you flip it over to magnetic?
Ooh.
Oh, wow.
And go ahead and lift it up just so we can see. Go ahead, it's all gonna stick there. So look at that. That is magnetic powder holding to the end of the brush.
cool.
That's why it's a magnetic brush, right?
This is like a Etch-a-Sketch. It's like an Etch-a-Sketch.
It is. It's
Yeah.
totally like an Etch-a-Sketch. Okay. Now, Becca, I'm going to give you a couple pieces of instruction here. Okay. You're going to pick up some of that magnetic powder, and you're going to treat it almost like a brush. Now, we have fingerprints somewhere on the back side of this mysterious bread pan here. Okay.
That much?
Yeah, the amount that you had. And what we're going to do first, Becca, is, and don't do it until I give you sort of the whole instructions. Magnetic powder is a little more corrosive than typical fingerprint powder, because it has those little chunks of metal in it. So you're just going to lightly go over the surface and try to pick up those fingerprints, okay? Just by releasing some of that magnetic powder. And you can do it a little bit heavier than that, Becca, because we want to knock some of it off.
Am I knocking any of it off?
Yeah, okay, there. See how it's kind of sticking? Yep. So we're just going along there, trying to rub some of it off. And the nice thing is we'll be able to pick it back up, the extra stuff back up with the magnet afterwards. So Becca's just going to go over the whole surface. You can be a little bit more forceful than that. Oh, you getting something?
Look at, somebody's been messing with your bread pan.
Somebody's been messing with my bread pan. So, although I'm sure it's hard to see from the camera angle, Becca's starting to reveal a finger there. Okay. See if you can find anything else there, Becca. I should have done like interesting shapes.
There's one.
Another finger.
I found another finger.
And again, apologies to viewers at home that you can't see this directly. We'll hold it up and show you sort of what we're looking at here in just a second.
Oh, there's another one.
So we got 3 fingers, huh? And if you need to get more magnetic powder, you can, Becca, if that stuff's sticking too much.
So we're looking for somebody with 3 fingers.
Well, a 3-finger person.
3-fingered man.
Nate, you're a crack detective.
I am.
All right. So, and the great thing about the magnetic powder is if you get a little too much down, if you know if the magnet were to go off and Becca was to drop all of it. Actually, let's just simulate that, Becca. Can you just lift it up gently and turn off the magnet? All the powder should fall.
Oops.
And you're like, oh no, I put too much powder.
Oh no,
but it doesn't matter because you can just turn the magnet back on and pick that all up. Okay.
Wow, that's so cool.
Becca, let's drop the remainder of that powder back in the thing.
This is pretty special.
It's kind of neat, right?
Yeah.
So now let's bring the magnet back over here and let's just try to pick up that excess powder by turning the magnet back on and getting any of this stuff. Now, luckily, the stuff that's attached to the prints, and we don't want to touch with the metal, just kind of go over it. The stuff that's attached to the prints should stick because it's oily. And the oil is what the powder is sticking to.
So the magnet's not strong enough to pull it away from the oil.
Exactly. It's just strong enough to pull it off of the glass. Okay. And then we just need to get some contact tape ready for Becca. Nate, can you help her out with that? Maybe pull off a little strip there.
Never find the end of these. Can you show that to the camera there?
Yeah, let's sort
While
of lift it
I'm
up.
searching.
I don't know if you can see.
Kind
It's kind of.
Do you have any
hard
forensic techniques to
You
find
can
the end
kind
of
of
the
Yeah,
just
you
see
can kinda see
right
the
here
two.
and right here. You can maybe make out those fingerprints. They're very light. Which is often the case with fingerprinting, that you're dealing with these very light prints and you're using different techniques to try to get.
Well, there are 4 of them. I do see 4.
All right. So
here's
Becca,
the
go
tape.
ahead. And Becca, you may not be able to get multiple fingers, so maybe let's just try to get one good finger, if that's possible.
Which one do you think is the best? Probably.
Yeah, I think that one's
Yeah,
pretty good.
middle.
That's what I would go for.
This one has a lot of powder, though.
Okay, whatever you think is best.
I don't
You are the
know.
detective.
I've never done this before. And I just.
Yep, you just kind of rub it on there just to make sure that it gets on. Again, gloves being super crucial, because if Becca was doing this with her ungloved finger, she'd be getting her own oil all over there. Okay, Becca, and then you can pull that off. And I'm going to give Becca a piece of contact paper here for her to put
Gloves
this
are
print
too
on.
big. Okay.
Do we get a transfer? A little bit? Not really? A little bit. Yeah. Let's see if we can see it all on the contact paper.
Let's try that one.
Just a little bit. There is just the littlest bit. I think we could probably do even more. Let me just try really quick. Let's see really quickly here. I'm just going to try to add a significant amount more.
Sneak this past.
Oh,
Sam.
sorry. I got those big broad shoulders that block the close-up
Sorry.
camera. I'm just going to see if I can dab.
Get this one, too.
This one oily?
Yeah, because that one's a greasy one.
Oh, those greasy fingers.
Yeah. So you could just dump it on there and then, like, magnet it up. Yeah, that's so cool. Okay.
Let's try that
Get some
one.
more tape.
Contact tape, Nate.
It's going to work. I know it.
That's right. We're crack squad of detectives at this point.
So with the more modern digital way to scan and stuff like that, is it? So what do? They have like a little digital scanner, or do they still?
In some cases,
Yeah.
they're doing it with a digital scanner. In some cases, this is often still the best way to do
Oh.
it in the
That's
field.
how I've seen them do it.
So this is if you're going out to a house or something,
Yeah.
you're going to try to do it like this.
Okay.
But luckily for us, whereas you used to would have had to bring it back to the lab, look at it under a magnifying glass, and really get a good sense for it, and compare it to perhaps ink prints that are on file. Now we can take these, and a computer can digitally pick up all of the powder and oil and really get us an accurate fingerprint.
And,
And look at a much bigger database of fingerprints
Right,
on file.
and the computer's going to be able to do a much better comparison job than we will.
Is it true that no other fingerprints are the same? Like each one is totally
Yeah,
different?
so all fingerprints are unique, and there's definitely similarities. There's about 6, I might be saying this wrong, but there's a number of different styles of fingerprints that people can have with different names, certain kinds of
Loops,
swirls or loops, right, that are very distinct. But then even within that, Jeff, if you and I had the same, let's say, to like a whorl fingerprint is one of the kinds.
Yeah.
If you and I both had that on our index fingers, there would still be differences between yours and mine. Is that one a little bit better, Becca?
I don't know.
I don't know either.
It's a bit better. You can see some print going on there. You can see a little loop in the middle.
Oh yeah, there's
Well,
And if you want to get a little bit more definition at home, I just had our staff
I'm
backstage.
trying to see it right there.
Yeah,
Yeah.
not super clear. But I had our staff backstage touch these objects for me to get some fingerprint oil on there. If you want to do this at home and just get sort of the full effect, another good way to do it would be to put lotion on your hands or put lotion on the hands of the person who is going to make the fingerprints. And that will allow the fingerprints to be revealed a little more clearly. Of course, that's not realistic,
Right.
because there's not really so many criminals
Some
that
guys-
put lotion on
and
And then go touch everything.
right
They were
before
gloves,
they do
those
the
little
The
jerks.
bad guys, they wear gloves.
The
So
bad
anyways.
guys.
Thank you guys so much for joining us here in the science lab. We're going to be back in the Homework Hotline studio in just a couple of minutes.
I just love the opportunity that Emily Griffith gives to me. My name is Delonda Franklin. I always just loved the legacy of the school. I graduated from Emily Griffith High School when I was 17 years old. It took me 3 years to get to this moment. I did not expect to enjoy it as much as I did. If that's in your heart and in your dreams, your goals, you have to fight for what you want.
Welcome back. That was really cool, Sam.
I'm glad you enjoyed it. For folks at home, I apologize if it wasn't as visually astounding as it was for us here. Definitely a cool thing to do in person, so consider trying it yourself.
Is there anything that they can use instead of the fingerprint powder? Like, could they use something at home?
Yeah. So like a simple clay powder. I'm trying to think of what the kind of clay is, but the kind of clay that you would get to make makeup base out of, I think.
Oh, okay.
Or, you can usually find that in like Whole Foods type stores. Cornstarch can also be used. The issue with cornstarch is it's a white powder.
It's just white.
So you want the contact paper to be black, to get the full
Oh,
effect
yeah,
of the
right.
fingerprint.
That makes sense.
Cool.
Yeah.
Yeah.
Really cool. All right, well, let's go back to Jeff and tell our audience the trivia question one more time to give them a chance to win.
That's right. You can win a prize.
Win.
What's the deal? No. But we have the trivia question is, what is the deepest shipwreck ever found? That is the trivia question. So come on, we need your answers. We need your attempts. So call in, get us on social media, whatever you want to do, but get us that so you can win your prize. What is the deepest shipwreck ever found?
Okay. Well, do we have time for a quick question?
We do, as a matter of fact. And actually, you know what? I'm going to go back to this question over here. What is
quick math one.
this is a quick math one here. Now this is Roman numeral subtraction problem. Now the way I know Roman numerals is from all the Super Bowls, you know, like Super Bowl 1, 2. I mean, that's how I know Roman numerals. But this one's cool. A little problem here. It's got let's see, XXVII minus XXIV.
You want me to take this one, or you got it?
27 minus 24?
So
Yep.
Super Bowl.
It's 3?
3.
Done.
I think the answer you're looking for, Rebecca, is I.
I. You're
Yeah,
right.
it's
You
actually
are
the
right.
answer.
Yep. I.
Okay.
Well, that was a quick one.
Yeah, that was cool.
So just so you know, if you were asking this question, you might not be able to interpret the
Right.
Roman numerals. The X's mean 10, the V's are 5, and the I's are all 1s. The unique thing, so that first value is, like Becca said, 27.
Yes.
The unique thing about Roman numerals is if the I comes before the V, it subtracts. And that was, I think, the way they differentiated. Should it be 5 plus 2 or 5 plus 1 or 5 minus 1? They put the I in front of the V. That's why that second one is not 26. If you just added all those up, you might think 26. The second one, because the I is in front of the V, you take the 5, you subtract 1,
So
and you go
24.
from there.
And then M is like 1,000 or something like that. Is that right?
Something like that.
Or it was 1,000.
Yeah, I think M is 1,000, C is 100.
When you look at the end of the movies, after the credits, it has the dates that it was produced, and it has it in Roman numerals a lot. I
Right.
don't know
I
if
think
you
L is,
I never
L is
noticed that.
50, D
L is
is
50.
500.
Uh-huh.
There's some other ones.
I didn't know D.
Yeah.
But
Cool.
yeah,
I
Super
prefer
Bowls.
just the numbers.
Super Bowl.
Yeah, it's not a great system to be perfectly
Super Bowl
honest.
L, the
but
Broncos
It's not, it
won.
has no zero either, which
Yeah.
is hugely problematic
right.
for complex math.
it is
All
actually
right, how
a lot of.
about another science question? And
Okay.
this kind of relates to kind of what we were talking about earlier. Why does ice float on top of water instead of sink?
Yeah, okay, so ice floats on water. This is so similar to the candy question, right?
Yeah,
So
right.
candy floats.
Someone's learned
When
about
candy
density.
floats, it's less dense. And when candy sinks, it's more dense than water. Right? That's the whole question about whether something sinks or floats. Is it more dense or less dense? The cool thing about ice, or the thing that should make you stop, is that most things, when they become a solid, become more dense than their liquid form. Ice is really special. Water is really special in that when it goes to a solid form, it actually is less dense than its liquid form. Really briefly, if we could just jump to my screen, I'll do this very fast. Liquid water can move around a lot. The molecules of liquid water can move around a lot, and so liquid water molecules can actually get closer to each other than solid water molecules, because solid water molecules get locked into this special crystalline structure due to the fact that water molecules have a positive end and a negative end. The positive and a negative end of water molecules can bond together through something called a hydrogen bond, and that sort of forces when water molecules get slow enough to become ice, sort of forces them to be in a fixed position, which gives them this crystal structure. They expand more than they would if they were liquid, which is why also you may have seen, oh my God, where is it? Water bottles explode in the freezer. Don't fill your water bottles up too much in the freezer, because the water will expand as it freezes, breaking the bottle. So if you have a water bottle you want to have in the freezer, just make sure there's a little bit of airspace for that water to expand into as it gets colder.
Okay.
Cool.
Nice. That was like super fast.
I was trying. I
That
know.
was super
sometimes,
efficient.
Sometimes
You
I,
had your pictures
sometimes
ready.
I just like tangent at the end of the show.
Yeah.
I'm just like, let me talk for 10 minutes about this idea. I know I'm
That
not
was
supposed to.
great. All right, time for the answer.
Oh, yes,
For the
time for the
question.
answer.
No winners, guys. You're crazy.
Come on, you gotta. Okay.
Gotta
So the
guess at
question, let's
least.
repeat it one more time. What is the deepest shipwreck ever found? And the answer is the SS Rio Grande at 5,762 meters. All right, now let's a little bit about the SS Rio Grande. It was a German warship from World War II. It was a blockade runner and was sunk by 2 U.S. ships on January 1st, 1944. The ship wasn't the only ship sunk that day. There were also 4 ships sunk. One was another German ship, and there were also 3 Japanese ships sunk. The ship was found using sonar technology, and the company Blue Water Recoveries found the ship on November 18th, 1996. Wow. So that's pretty cool.
And just so you know, because we're the only country that doesn't really use the metric system, and maybe if you're not familiar with how much a meter is, so you said that was what, 5,500 meters or so? A meter is not the same as a foot, if you're not clear on that. 1 meter is about 3.28 feet. So if you wanted to convert this and figure out how deep it was in feet, see, it makes it a little bit more, I don't know, it's a little bit easier to relate since we all use feet here. 5,762 meters is 18,904 feet. So
Wow.
that is pretty deep. And I was actually wondering, I mean, what would that ship look like? I mean, was all that water pressure going to...
So I literally
it,
just
or-
calculated the water
Yeah.
pressure. So every 10 meters you go down in underwater, you add 1 atmosphere of pressure, which is approximately 14.5 pounds of pressure. So just generalizing the numbers, it's about 8,000 pounds of pressure per square
Wow.
inch
Wow.
That is a
at
lot.
that depth.
Wow.
So I wonder what that looks like
I mean,
now.
to a human, it would look like crushing them. To a boat, the metal of the hull is going to be able to take it. Any
Okay.
windows, anything that is able to be compressed, surely is destroyed.
And with corrosion, like and oxidation.
Oh, would that weaken it? And
Yeah.
then possibly...
Yeah, actually, that's really a good question. I'm actually not sure about whether whether that high pressure would increase the level of oxidation or would actually be protective.
Okay.
In a sense, that's something I'll look into, and maybe on another show
Kinda
we can
wonder.
talk about it. But I don't know.
Is it actually possible to raise a ship? Like I know people always talk about raising the Titanic and stuff like that.
Yeah.
Is that, I mean, with all that pressure, is there a possible way to get all that to?
That's interesting. Yeah.
It is possible because we have really great technology, because we can actually exert that much force.
Okay.
You know, we can figure out a way.
But you would need to counter that 8,000 pounds of force. Like, so you need
Yeah, that'd be
8,000
something
pounds
else.
of pulling
And
force.
actually, the Titanic is not as deep as the SS Rio Grande. I wonder if this is so deep that it might be too much. So I'll look into these two things. I'll look into whether pressure underwater increases or reduces corrosive capacity of the water, and whether we can actually bring up sunken ships.
I like it.
Awesome.
Well, you better have answers for me next week.
Tuesday.
I'm gonna
Next
get 'em.
week.
Next
Tuesday.
Maybe,
So-
maybe you guys can send those questions in.
Yeah.
So send those questions in. We will see you again next Tuesday from 4:30 to 5:30. So I am expecting answers, Sam. And we're also here Wednesday from 4:30 to 5:30. That'll be those will be our last two shows before we go for Christmas break. So
So you're on your own.
yeah, you're on your own. So get those questions
All your
in
Christmas
for us.
homework, no help.
Yeah.
Yeah, none whatsoever.
Maybe from Santa.
Yep.
Not from us.
All right. So thanks for joining us again today. We had a lot of fun with you. We'll see you next week.